Hello. Hi. How are you? Good morning, students. My name is Samuel Chukwu Emeka, as usual. In this video, we shall discuss your Module 2 homework study guide. So let's go to my website. As usual, you click on my picture to enter the site. You click on mathematics. You scroll down to finite math. And the video that we are going to do now will be in this playlist. I will upload it in this playlist. We can go to the notes. I have already uploaded the notes. Module 2 homework study guide. What are the objectives? We will organize data in frequency tables. We shall calculate the relative frequencies of a data set. We shall construct a relative frequency distribution of a data set. Then we shall also construct bar graphs, pie charts, histograms. We shall identify the shape of a distribution and also interpret data, the data that we present in bar graphs, pie charts, histograms, and frequency tables. We shall interpret the data. So what is a frequency distribution? We say that a frequency distribution lists the number of occurrences, which means it lists the frequency, because frequency is the number of occurrences. You probably use the word frequent. How frequently? You know, how many times does it occur? That is the frequency. So a frequency distribution lists the frequency of each category of data. Then we also have a relative frequency distribution. That gives us the proportion of the frequencies or the proportion of occurrences. So you kind of see the difference here. The frequency distribution gives you the frequency. Then the relative frequency distribution gives you a proportion of the frequencies or number of occurrences. Okay, proportion of it. So it's relative. It's relative. The shape of a distribution, we say it could be uniform symmetric. If the distribution looks this way, it is known as a uniform symmetric distribution. If you see it like this, you know, you have a peak here, and you have this is like symmetrical here. But you have a peak here, like a normal distribution curve. We call it a uniform bell-shaped curve. Okay, we say it is uniform bell-shaped when you see the distribution like this. If you see it this way, whereby the peak is on the left, but the tail is on the right. You see the tail is on the right. We say it is a skewed right. Okay. And if the tail is on the left and the peak is towards the right, we say it is skewed left. So this is a uniform symmetric, is uniform and is symmetric. This is bell-shaped. Okay, like your normal distribution. If the peak tends towards the left, but the tail is towards the right, then it is skewed right. And if the tail is towards the left and the peak is towards the right, it is skewed left. If we look at something, examples, the heights of full-grown men, you know, if you look at full-grown men, some of them are short, some are middle, average height, some are tall height, 6 feet, 7 feet, right? Basketball players are within this height. And you know, that is kind of a bell-shaped symmetric. If you look at the ages of patients diagnosed with Alzheimer's disease, it is something like skewed left. You know, if the ages, the Alzheimer's disease is towards as somebody gets older, you don't often see Alzheimer's disease in young people. So this is like young ages, and this is older ages. So as people get older, then there is high probability, you know, in older adults. You don't usually see that in young kids. So because of that, we say it is skewed left. Okay. If you look at the annual household incomes in the US, skewed right. Well, you might say that this is skewed right. As the economy is yet to improve, you know, the economy is not where it is now. I mean, there is so much inequality gap now. We have so much inequality gap. I will install that later on. So the middle class is fading. The upper class does not want middle class to come up, you know, and they even want to push the middle class back to the low class, and the upper class still want to maintain their upper class. High inequality, and that is the problem we have in this world, inequality. So it's skewed. You can say it's skewed right. You know, if you compare the economy maybe some years ago and the economy right now, you could see that the annual household incomes are staggering. You know, so you could say it is skewed right. Question 7. The Pareto chart, this is a Pareto chart, represents the number of seniors in 6 high schools. So if you look at this chart, East Lake is more than 1,100 seniors. West Central High School has about, you know, between just like almost, is really less than the middle of it, of 1,100, right? Edison High School has 1,000 high school seniors. North Waverly High School has about 850. Deerbrook High School has about 750. If you look at this, it doesn't really look to the half of it. That's why I didn't say it was half of it. It's just lower than half of it, though. You know, between 1,000 and 1,100, you have a 1,050. It's a little bit less than 1,050. But this one is 1,000, Edison High School. North Waverly is about half of it, 850 high school seniors. Deerbrook has about 750. Blantonburg has about 650. So, which high school has the most seniors? You see, it's Eastlake anyway. It has more than 1,100 high school seniors. What is the number of seniors in Edison High School? Edison is the light green, or is it lime? Is it lime color or light green? So Edison is about 1,000 students. You see it right here. That is interpretation of data. Okay, interpretation of data in a Pareto chart. Then it says how many more seniors are in Deerbrook High School than in Blantonburg High School. So we have to find how many. Deerbrook is the green. That is 750, and then Blantonburg is this color. What's this color? Well, you tell me what's this color. Is it it's not cyan, right? Anyway, I don't know the color. But it's 650. So you do 750 minus 650. Gives you 100. Okay? Any question? All right. Question 8. The ages of the males and females who received tickets in Lake City, Florida. You have these age groups being given tickets. This is in thousands. This is 27.8 thousand. Okay. These are the males in thousands, and these are the females in thousands. Okay, so construct a relative frequency distribution of the males who receive tickets, then do that of the females, and then construct a side-by-side relative frequency bar graph. So this is the formula for relative frequency. We will have to calculate the total frequency for the males. Okay, and then we do each frequency divided by the total frequency. That gives us the relative frequency. So we shall do that for the males, and we shall do that for the females. If you look at this, if you add it up, let me get my calculator. You know, this is Windows 8, so you just go to the top edge, click on the search icon, type in calculator, and this first one. Usually when you find this calculator, it is like this. It's in standard. So what you need to do, just click view, put it in scientific. And if you add this up, remember this is in thousands, but that is fine. If you add 27.8 plus 17.8 plus 15.8 plus 8.0 plus 12.4. So that gives you 81.8. Come on, Mr. C. I probably did something wrong. 27.8 plus, don't mind me, okay? 17.8 plus 15.4 plus 8.0 plus 12.4. So 81.4, you see that, okay? Don't mind me, I probably did something wrong. Okay, this is the total frequency for the males. So if you want to find relative frequency, that is the formula right here. The frequency of each one divided by the total frequency. That is the formula. And they want you to round to 3 decimal places. Okay, so we have to do each of these frequency and round it to 3 decimal places. So if you do 27.8 divided by 81.4 equal to, so 0.342. Do you see that? That is the way you calculate this. Okay, let's say, I made a mistake initially. The first time I calculated the frequency. I made mistake, right? I think I got 81.8. You saw it. But the total frequency was 81.4. Okay. How do you know whether you are correct? You can now use StatCrunch to check your work. Okay, so I'm just gonna write this down. I'm gonna write it down on a piece of paper so that 27.8. Well, 16 to 25, you have 27.8. 26 to 35, you have 17.8. You write it on a piece of paper like I am writing now. 36 to 45, you have 15.4. 46 to 55, you have 8.0. And then greater than 56, you have 12.4. You have this as age groups, and you have this as frequency, males. So, I will just show you an example of how to do this with StatCrunch. I already have my StatCrunch open. So, for each question, you see on the right-hand side, you see the StatCrunch icon. So, I'm just going to pull up my StatCrunch right here. So, I have this StatCrunch open. Let me just extend this space. Here because you can use this to verify, your work to make sure you don't get it wrong. You can say age groups, and then here is frequency. Okay, males, and let me put this in camel case. So right now I just want to do frequency males. Okay, for that. Then I have 16 to 25. I have 26 to 35. You see how I used camel case. It is better you use camel case to name your variables. Okay. 36 to 45, 46 to 55, and then greater than 56. Okay. And then in the frequency, I have 27.8 thousand. I'll just leave it, without writing the full amount. I know that this is in thousands. 17.8, 15.4. 8.0, and then 12.4. Okay, you go to, they want us to construct a side-by-side relative frequency bar graph. Okay, so you go to graph here, graph, bar plot with summary. Go to with summary. The categories are these are the categories, your X. So you select age groups. The counts is frequency males. You select it. And you don't need to check this. You don't need to check it. Just you select this. And the type is not frequency. You want to select relative frequency because that is what you want, right? That is what the question says. Construct relative side-by-side relative frequency bar graph. So you select it is by default it is on frequency. You select relative frequency and you click compute. Okay, and this is what you have here. This is what you have here. Now, if you want to check, all you need, whether you got those the calculations right, all you need to do is you point your mouse here. Do you see that? When you point your mouse there, what do we have? 0.34152334. Round it to 3 decimal places, you have 0.342. That was what we got, right? 0.342 gives you the relative frequency right away. If you point it, the next one is 0.219. So you point this, you see that 0.219. So when you point it, you actually get the relative frequency. So it kind of, you check that. I would not want you to just do an easy way like this and then you go and relax. You will need to know how to use your calculator to add it up and then compute the relative frequency. Okay? I'm not monitoring you, but this is just a suggestion. Okay, so when you do that, you have it like this. Relative frequency age groups. This is for males and this is for females. Question 9. An experiment was conducted in which 2 fair dice were thrown 100 times. The sum of the pips showing on the dice was recorded. The frequency histogram below gives the results. So they already gave us this. What was the most frequent outcome? So if you look at this, because frequency is always the number of occurrences, or the counts, or number of occurrences, or counts, C-O-U-N-T-S. You look at this is a bell-shaped, okay, normal distribution curve or bell-shaped curve. This has a frequency of 20, and what is there is 7. That is why the most frequent outcome is 7. 20 is the frequency, 7 is the outcome. Okay? What was the least frequent outcome? Is this little guy right here. And that is 12. Okay? So, because this tells you that 7 occurred 20 times. That's what it tells you. Okay. How many times was 11 observed? 11 occurred how many times? This is 5. Okay. This is like 5, 10, 15, 20. So 11 occurred 5 times. You see that? And 12 occurred like probably 1. That might be 1 or 2. Might be 1. Now, the next thing, determine the percentage of time an 11 was observed. So when you are asked to find the percentage of time an 11 was observed, you first of all find the frequency of 11 divided by the total frequency, then times 100%. So, it is just like saying the relative frequency times 100%. Remember, the relative frequency is the frequency divided by the total frequency. That is what we know as the relative frequency. So when you multiply that by 100%, it gives you the percentage of time that occurred. It's just like saying this, okay? If I have 10 students in my class, 5 are girls, 5 are boys. What is the percentage of girls? So you first of all say, how many girls? What is the frequency of girls? How many girls do we have? It is 5. What is the total frequency? What is the total number of students in my class? It's 10. So 5 out of 10 will give you the relative frequency of the girls. The frequency over the total frequency. And that gives you 0.5. And then you multiply that by 100%, it gives you, 50%. So it's the same thing here. 11 was observed 5 times out of 100 times. So the relative frequency will be 0.05. Multiplied by 100 is 5%. Or you can just say 5 out of 100 times 100 over 1. The 100 cancels the 100. 100 at the denominator cancels the 100 at the numerator. And then you have 5%. Okay? What is the shape of the distribution? We talked about it. It is bell-shaped. Okay, question 10, we come to a pie chart. Some textbooks will call it pie secograph. Some textbooks you see it as pie chart. Some textbooks will call it secograph. So this pie chart shows the beverage sizes chosen by customers at McDonald's. You know, this soda is something else, honestly. Makes somebody to have big stomach. So, A, the most popular size is what? You see, 22% of McDonald's customers take a small size of soda. 16% take a medium size of soda. 52% take a large size of soda. And 10% take extra large size of soda. Water is better, much better than soda, you know, but I'm not gonna come and start going into political issues. Otherwise, somebody like Sarah Palin might drink might drink another big gulp of soda. Okay, so the most popular size is 52%. They like large sizes. Okay. Then the least popular size is what? The smaller guy. The smaller 10% is the extra large is the least popular size because it is chosen by the smallest percent, smallest size of smallest percent of customers. Medium size is 16% and the small size is 22%. That's pie chart. Interpreting pie chart or circle graph. Question 11. The table below represents the land area and the highest elevation for each of 7 counties in a Nigerian state. Okay. So this is the land area and this is just the highest elevation. Would it make sense to draw a pie chart for the land area? You know, land area covers the entire land, okay? So when you're drawing a pie chart, it will make sense if all the categories are present, okay? Because this is the entire land area, yes, it will make sense to draw it. But it will not make sense to draw the highest elevation. Why? Because this is just, if we said total elevation, you know, if we said, you know, if we said this is just highest elevation. Do you understand what I'm saying? It's just highest elevation. With pie chart, for you to draw a pie chart, it has to represent all the total categories will be present. This is just highest elevation, which is like the peak. So it doesn't really represent the total. So because of that, it would not make sense to draw a pie chart for it. Okay? And let us go ahead and draw this pie chart right away for the land area. So I'm going to show you how to do it on StatCrunch, but I'm gonna write it out on my paper. So I am doing it so that is what, you know, to advise you to also do it. So I have land area and then counties 11,305, 5,101, 14,215, 3,132, 3,837, 9,449, 6,879. Because it's good you know how to use technology to do this, and StatCrunch is pretty much simple to use. So county 1, 2, 3, 4, 5, 6, 7. Okay, so I'm gonna go back to the StatCrunch, and then let me just close this. I can just use do this here, although if you want to delete the rest, that's fine. But let me write this as the counties, and here I write a land area. Okay, I use camel case, and I don't want to put space on the variable, naming of variables. Okay, so this is a county 1, county 1, and the land area is 11,305. You don't want to put comma, okay? Don't put comma. 11,305. No, don't do that. Then this is county 2, county 3, county 4, county 5, county 6, county 7. Okay. And then I come here, I have 5101, oops, 5101, 14215, 3132, 3837, 9449, and 6879. Okay, so I go to graph, I go to pie chart, I go to with summary. Each one I'm doing with summary, okay? And my categories here would be the X, the counties. Counties is what I want. And the counts, the frequency will be the land area, the total land area, okay? If you want, you could, select more than one click. If you want, you could display it as count or as percent or as both. Okay, you can do that if you want. So I'm just gonna leave it as both. Okay, I'm just gonna leave it as both. That is what you just, by default, you leave it as both, and then you just click compute. And this will be your pie chart here, right here. And of course, if you point at it, gives you the county, gives you the count, okay, the land area, and it tells you how many percent, the percent of total. So that is how to do it, okay? And you know that you can, if you're writing a report and you want to submit your report, you can always save this. You can click on options, you can save it, you can copy it, you can download it. Okay. Back to our video here. So when you do that, you have something like this. Okay. I think I just did mine with percent of land area, but if you want, you can still put the count and it will put it for you. Like this one has the count and the percent. Okay, next one. Consider the, ooh, what is that? Burger King? Why can't we lose weight? This is not just why can't we lose weight. It is why can't I lose weight? Because this cheeseburger made my stomach big. Before I came to US, I was, very fit, and I was athletic and very fit. But I ate a McDonald's cheeseburger, and I have big stomach, which I'm trying now to see whether I can get it to see whether I can get it in shape. Because my folks in Nigeria, they see my YouTube video and they shout, "What have you been eating?" So this is to me, this pertains this message, it pertains to me. Why can't I lose weight? Anyway, what are they asking here? Can you represent this in a pie chart? With a pie chart, there are two important things you need to know. The total angle, because a pie chart is a circle, and one of the circle theorems is that the angle in a circle is 360 degrees. Okay, just like you have angle in a straight line is 180 degrees, angle in a circle is 360 degrees. So the sum of all the angles in a pie chart is 360 degrees. That is the first thing you need to know. In fact, if we were drawing this pie chart on we use a compass. Okay, if you were drawing it on paper, if you were not using a technology to do it, if you were doing it with hand, which I did, you use compass to get the round circle, and you use your protractor to measure all these angles. You have to you calculate these angles. Okay, you calculate the angles, the sectorial, and we call it sectorial angles. So the first thing about a pie chart is the sum of the angles in a pie chart will be 360 degrees. Some of the sectorial angles. Then the second thing is that if you add the percentages, it must be equal to 100%. That is the second thing to note. So, but if you add up these percentages, add up all these, it's not up to 100%. So there's no way you can put this in a pie chart. No, you cannot. Question 13. The age distribution of 50 randomly selected students in Samdom for peace, Samdom's learning center is shown below. Construct a relative frequency distribution of the data. So, you know, the same thing we do. Okay, that is the same principle you do here. And one thing with, if you want to find the percentages, all you need to do is like this over this times 100%. Just multiply the relative frequency by 100% to give you the percentages. Question 14 gives you class. Okay, this is still age groups for those who receive tickets. How many classes do we have? 1, 2, 3, 4, 5. 5 classes. That is all we have. There are something, you know, first class. These are called class intervals or class limits. Like in the first class, this is the lower class limit or the lower class interval. Lower class interval is 18. Upper class interval is 27. Let me just use class limit because that is what your textbook used. So, but if you read another textbook and you see class intervals, it is the same thing. So, for the 5th class, lower class limit is 58. Upper class limit is 67. How do we find the class size or the class width? We call it class size or class width. Width. The TH is silent. Width. You know, you put your tongue in between your teeth to pronounce the TH. Width. That was how they taught us to pronounce that. Okay, so this is how you find your class size or class width. The lower class limit of the 2nd class minus lower class limit of the 1st class, or lower class limit of the 3rd class minus lower class limit of the 2nd class, or lower class limit of the 4th class minus lower class limit of the 3rd class. Okay, and the same thing, you can also do it for upper class limit. Upper class limit of 2nd class minus upper class limit of 1st class, or upper class limit of 5th class minus upper class limit of 4th class. Okay, that is the class size or class width. There is another method to find class size or class width, and that is what we call class boundaries. Okay, for instance, the class boundary of the 1st class is 17.5 to 27.5. Okay, so the class width would be 27.5 minus 17.5. But anyway, don't worry about that. Just focus on this. But this is another way to find the class size or class width. 15, you could also do the same thing, okay? You can go over it here so that I don't make this video so long. Okay, so you go over it and you construct the relative frequency distribution. I think this case I had to put the percent because they wanted another question. Let's see after they told us to graph it, they said side by side. So side by side relative frequency bar graph, you can kind of use inspection, you know, see all the graphs and use inspection to know which one is the correct one. Okay, so the same method is what you use for this one. I think this one they also asked for the percentages. Okay, and they asked you what do you observe. So, but that you use the same principle to graph it, to use your StatCrunch software to do the relative frequency bar graph. Okay, this is also relative frequency. Let's see. Next question. Okay, do the same thing here. You can put the data in StatCrunch and it will give you, you verify the relative frequency. Okay, but you also do this by hand. Then it says, what percentage of four-year colleges have tuition and fees below $4,000? If you're using this, I want to say something here. Below 4,000, you know, you might say add this plus this plus this and multiply by 100. Okay, you don't want to do that because if we do that, you know why? Because you've rounded up. When you are doing this, don't round up. Okay, percentage of four-year colleges that have tuition and fees. Let's start from the beginning. The table represents the cost of undergraduate tuition and fees for all four-year public and private non-profit colleges in a country in 1993. Round to 3 decimal places as needed. So we constructed the relative frequency. Okay, as usual, you find the total and you divide each frequency divided by the relative frequency. So the next question says, what percentage of four-year colleges have tuition and fees below $4,000? Round to the nearest tenth as needed. So don't come because you rounded to 3 decimal places here. Some people might say, okay, why don't I come and do 0 below 4,000 will give us 0.082, right? Plus 0.010. Okay, and you have this 0.092 and you multiply by 100 to give you the percent, 9.2%. Okay, that is not the answer. The answer is 9.1%. Why? You rounded this. Do not use the actual values. Okay, 16 over 1619 plus 132 over 1619. They have the same denominator, so you just add the numerator. 16 plus 132 equal to this 148 divided by 1619. So this is the total relative frequency of the colleges that have tuition below 4,000. If you now want to find the percentages, you just multiply by 100. And that gives you 9.1% because they asked you to round to the nearest tenth. Okay? So do not round until the final answer. That is what I'm trying to say. Do not round your answer until the final answer. Okay? Then what percentage of four-year colleges have tuition and fees of $20,000 or more. So this means that $20,000 is included, okay, or more. So we include this, we include this, we include this, we include this. Okay, so add this plus this plus this plus this. And when you do that, it gives you this. You multiply by 100%. By 100 gives you this. You round to the nearest tenth. Okay. Question 17. The frequency histogram on the right shows the proportion of people aged 25 to 64 years old not covered by any health insurance last year. How is this graph misleading? So when we look at this graph, this is 0.1, 0.15, 0.2, 0.25, 0.3. There is something that is misleading about this. It doesn't have a uniform scale. Okay, this should have started from 0, and then it should have a uniform scale, which it does not have. So this is the misleading graph, and this is the correct graph. How do you interpret this graph? It tells you this, okay? As people begin to age, the proportion of people not covered by health insurance begins to decrease. You know, young people usually don't want to buy health insurance. You know, young healthy folks, they don't want to buy health insurance. But then as people begin to age, you know, the proportion not covered by insurance begins to be small, because the older people want to buy health insurance. So that is what this graph, that is the interpretation. As the age increases, the proportion of the people not covered by health insurance decreases. Okay? And these are the references. All right, folks, thank you so much for listening to this presentation. If you have any questions at all, feel free to ask me. Watch out for other videos. And you have a great morning.